last section in Chapter 1, Section 8, functions, looking at a function. So we're looking at graphing, we're going to be looking at using functions, making ordered pairs, we're looking at some vocabulary. A little bit of vocabulary. So the coordinate plane is formed by the intersection of two perpendicular lines. These number lines are our x-axis, which is really in red. So this would be our x-axis, and that's our number line. That's our typical number line. In fact, I think the reason I got rid of that is this one right here we have is called the x-axis. You can fill in that as the x-axis. X-axis is our typical number line. -1, -2, -3, -4, 0, 1, 2, 3, 4, etc. And then the vertical axis, which is the y-axis, which is another number line. We have a -1 on there, we have a 1 on there, 0's on there, so it's another number line. And we put those together, we put those two number lines together, we get a two-dimensional grid. We get a two-dimensional grid, and we call that, we call it axes, the x-axis, the y-axis. The middle, where those two intersect, where those two axes intersect, y-axis and x-axis, we call the origin. The origin is where everything originates from. That's where the beginning. You originate from someplace. All of humankind, if you believe in evolution, would originate from somewhere near Iran, Iraq, the Middle East. That's where the species originated from. Again, if you believe in evolution. 0 on both the number lines is the origin. Everything starts at 0 and it goes from there, either to the left, to the right, up, or down. And again, on these, the vocabulary, the word, the paragraph here with the x-axis and the y-axis. So the horizontal is the x-axis, vertical is the y-axis. And we will deal with those in a minute. Just remember, x comes before y. That's important. It's easy to remember, too, hopefully, that x comes before y, just like in the alphabet. So I'll fill that in. The origin is the middle, is where everything starts at 0, 0. And we also have these quadrants. When you break the x-axis and the y-axis up here, we end up with 4 different quadrants. We have quadrant 1. Oops, just went black. There we go. We have quadrant 1. We have quadrant 2, quadrant 3, quadrant 4, and it does go counterclockwise, you'll notice. 1, 2, 3, 4. So it's not a clockwise rotation. That comes from trigonometry. When we start looking at angles, we start going this direction with our angles. And so that's why it's quadrant 1, quadrant 2, quadrant 3, quadrant 4 in that direction. It's just important that you know what they are, or where they are. And so quadrant 1 is right here. You can use this on your test. You can use these notes. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. A question on the test might be, what quadrant is this point in? You would answer quadrant 1. That'd be it. Where is it? It's just a way of identifying things. Okay. So, points in the coordinate plane are described by using ordered pairs. Ordered pairs, and we have these ordered pairs, and they consist of x coordinates and a y coordinate. We typically write them in this fashion: x, comma, y, with parentheses on either side. And so an ordered pair is an x coordinate and a y coordinate. It's a lot like where if you tell somebody where you live, you don't say I live by the oak tree near the pine tree. You say I live on maybe 8th Street and 7th Avenue. So where do you live? 8th Street and 7th Avenue. That's an ordered pair. It tells us a lot of times streets are broken into a grid. You have your avenues, there we go, and you have your streets. And so if you live on the corner of an avenue and a street, you're telling these people exactly where you live by a street and an avenue, an X and a Y. So we use this to identify where things are as a location. Graphing. So part of this is going to be taking an ordered pair and putting it on a graph. Part of it is going to be looking at an ordered pair, looking at a graph, and telling where is it. So point T, all right, pause it, try these on your own. Plot T, U, and A. and see if your plotting matches my plot. So pause it, plot these points, we'll see if we match. I'm assuming you pause it, assuming you try it on your own. I'm going to plot negative 4, 4. So again, when I'm plotting, I start at the origin, 0, 0, and I go from there. So negative 4, 4, x comes before y. We should have x to negative 4, y to 4. There's the point, negative 4, 4. So I would plot the point, negative 4, 4 right there. And I'm going to label that point T. If you didn't label it, make sure you label it so I know which is which. The next one, u, 0 at negative 5. So again, the x is u, the x is 0, and the y is negative 5. So 0, I start at the origin, 0, 0. Go 0 left or right. I go down to negative 5. So the point u is at 0, negative 5. Right, I'm going to label it there, u, that's where you are. And the next one then, A, again, here's my x and my y, just like in the alphabet, it goes x and then y, negative 2 and negative 3. I start at the origin, always at the origin, such that things originate from. Negative 2, negative 3, I go negative 2, negative 3, and there's my point A. Right there. And so you should have an image that looks very similar to this. Negative 4, 4, 0, negative 5, negative 2, negative 3. And again, it's important to do x and then y, so I go left and right first from the origin, and then I go up and down from there. Going the opposite way. Identify which quadrant each point lies in, and then I would also like you to put the coordinates, put the ordered pair. So locate the points in the coordinate on the coordinate plane, name the quadrant, which quadrant is the point in, and then I also like you to tell me what the coordinate is for that point. So put it down as an ordered pair. Pause it, try this on your own. Assuming you pause it, assuming you tried it on your own. So if I'm going to try and find the point E, there it is right there. E, which quadrant is it in? Well, here's quadrant 1, here's quadrant 2, quadrant 3, quadrant 4. So E is in quadrant 2, so I'm going to put the E is in Q2, quadrant 2. Do I use Roman numerals? Go for it. And then I'm also going to identify it as an ordered pair. E is at the point negative 3, 2. It's on the intersection of negative 3 and 2. So it's negative 3x and 2y. F. Same idea for F. F is right here. And the ordered pair, well, if we start with the origin, it goes left and right 0. So it does not go left or right on the x-axis at all. And the up and down, the y-axis, 3. So you should have 0, 3 as your ordered pair. Which quadrant is it in? That's a tricky one. A point technically has no width. It does not have any width at all. Even though we look at point F and it looks like it has a little bit of back and forth on it, it doesn't technically have a width, which means it can't be in point for quadrant 1.
Can I please have a custodian call 5247? A custodian call 5247.
Not be
Thank
in
you.
quadrant 1 and quadrant 2 at the same time. What we say is that if there is no quadrant, it's not in a quadrant. I'm going to put quad. It is not in a quadrant at all. It's on the y-axis. So we say no quadrant, y-axis. Those are a little bit awkward. So it's not in quadrant 1, it's not in quadrant 2, it's right on the y-axis. So we say no quadrant, y-axis. Next one, G. G is right here. And so it goes over 4, up 1. So we have a quadrant 4, coordinate 4, 1. And it is in quadrant 1. The answer for that, quadrant 1, 4, 1. And the last one for point H. For point H, we go negative 1, negative 1. So that ordered pair, negative 1, negative 1. And the quadrant, then we would say it is in quadrant 3. Because it's in quadrant 3. That's the only rationale really, is that's kind of where it is. It's in quadrant 3. Okay, if you're not sure where we're getting this, like, okay, I'm still confused. How did you get 4, 1? I don't understand these ordered pairs. Write that below in the paragraph area where you can ask questions. Say, I still don't get it. But let me know what you don't get. Functions. Moving on, I'm going to go a little bit faster. So, functions. Function is where you have an input and an output. A function is like a computer. You do something, something happens. If you click, something should happen. So input, something is going in, and then output, something comes out. So you do something, something happens. If you're playing a video game and you push button A, something is supposed to happen. And so if you push the green button, something should happen. That's an input and an output. That's a function. All right, so an engraver charges a setup fee of $10 plus $2 for every word engraved. A function for this would be that we have a setup fee of $10 plus $2 for every word engraved. And instead of W for word, instead of W, I'm going to put X, simply because that's what I see over here. So that would be an example of a function that we can write, y equals 10 plus 2x. Back, that's not quite the same here, but pretty close. So it's $10 for setup fee plus $2 for every word engraved. So there's our rule. And we're going to write some ordered pairs. And they told us a couple of sample words, that it could be 5, 10, 15, or 20 words engraved. So under the X here, these are the different words that I can have engraved. I could have 5 words engraved, I could have 10 words engraved, I could have 15 words engraved, I could have 20 words engraved. My function is going to go right in the middle here. So I'm going to have you write y equals 10 plus 2x. If I'm going too fast, pause it. And then I'm going to substitute. I'm going to say I've got this function, y equals 10x, or excuse me, 10 plus 2x. I have 4 different x values here. I'm just going to replace x with this first x value. I'm going to say y equals 10 plus 2 times 5. Let's see what happens when there's 5 words. Okay, now, 5. Now let's see what happens when there's 10 words. I'm going to write y equals 10 plus 2 times 10. So I'm just replacing x with whatever this value of x is. Y equals 10 plus 2 times 15. Y equals 10 plus 2 times 20. So when you're making these tables, we're really trying different situations. We're saying, what happens when x is 5? What happens when x is 10? What happens when, and we're substituting that in. Now let's see what it equals. So it says y equals 10x plus 2 times 5. Y equals, etc. So I'm going to see what that equals. 10 plus 2 times 5, or 2 times 5 is 10. 10 plus 10 is 20, so y is 20. This says y equals 10 plus 2 times 10. So we get 30. Y equals 10 plus 2 times 15. So I'm going to get 40. We should notice a pattern here at this point. 10, 20, 30, 40, it should be 50 next. If we're doing things correctly, sure enough, 2 times 20 plus 10 is 50. If you're doing things correctly, you should end up with a nice, clean pattern where it goes up by 10 every time, or it goes up by 5 every time. Once you've made your y column here filled in, the last column, x and y, well, x comes from right here, and y comes from right here. So x, y, 5, 20. When x is 5, y is 20. 10, 30. When x is 10, y is 30. 15, 40. 20, 50. So the x column we get from the problem. The problem gives us the x column, 5, 10, 15, 20. The y column, the function, was part of the situation, $10 plus $2 for every word. Y, the y column, comes from the equation, y equals 10 plus 2 times 5. And the last column, xy, comes from the x and the y column. We put them together, we just match them up. Now we got to graph it. So we've got 4 ordered pairs, 5, 20, So over 5, oh, I don't have enough room on my graph, what to do. I'm not going to make my graph go up to 50. That would be ridiculous. Instead, I'm just going to adjust the scale on my graph. So I'm just going to go by 10. So I'm going to make that 10, 20, 30, 40. That way, everything fits. So if it doesn't fit, don't make your graph bigger, adjust the scale so that it does work for you. All right, let's try that again then. So 5, well, I'm going to have to do that a little bit on here too. Let's go ahead and do 2, let's go by 5. So on the x-axis, let's go ahead and change it, we'll go by 5, 10, 15, 20, 25, etc. All right, so if I plot these points, I should have 5, 20, should be the first one. So I plot that point, go over 5, up 20. 10, 30, I go over to 10, up to 30. 15, 40, I go over to 15, I go up to 40. And 20, 50, I go over to 20. I should have a nice straight line if I did that correctly. And for all the ones that we're going to do in this section, you'll have a nice straight line with a nice pattern here. That was a lot. There's a lot involved there. I want you to go ahead and try this one on your own. For this one, I've given you the x's, I've given you the function. I want you to try filling in the table. So pause it, fill in the table. I'm assuming you paused it. I'm assuming you tried it on your own. I'm just going to put really quickly what they should be. If yours doesn't match, watch the linked video. That should be your x column. That should be your middle column. That should be your y column. That should be your ordered pair column. And again, if you didn't have a match on all those columns, watch the linked video so you see how it's done. And then graphing should be like, come on, where is it? There it is. It should look like that. So check your graph as well. Okay, again, if you didn't get those, watch the linked video, and good luck on the questions.